on studying the structure of a piece of copper conductor, we find the molecules of the copper are closely packed because it is a solid matter. Each copper atom consists of a free or mobile electron that can easily be discharged from its parent nucleus, detached from the parent nucleus. These mobile electrons that have thus detached themselves from the nucleus wander about aimlessly from atom to atom in random directions, while the positive ions are immobile in nature as they are embedded in the structure. The net transfer of electrons in any particular direction is practically zero, and no effective flow of electron in any direction take place. Let us now consider a circuit where the ends of the copper conductor are connected to the terminals of the battery as shown in figure. Since like charges repel and unlike charges attract, the positively charged plate of the battery provides an attracting force over the wandering electrons, and negative plate repels these electrons. These forces make the wandering electrons to systematically drift towards the positive plate of the battery along the length of the conductor. Then once some of the electrons are captured by a positive terminal from the material, the copper conductor becomes instantly charged, and in order to neutralize the charge, equal number of electrons will be forced from the negative terminal of the battery into the material. In this way, there is a steady flow of electrons from the negative terminal of the battery into the material and through the material to the positive terminal. This steady flow of electrons is known as electron current. In early days, long before the electron theory was well known, it was believed that when a battery's terminals were connected by a conductor, something called electric current was flowing through the conductor, and it was assumed that this flow of electric current was from positive terminal to the negative terminal of the battery through the externally connected conductor. We too will follow in line with the same school of thought, and in all our future references, we will only talk about electric current flow from positive to negative terminal of the battery through the external circuit, meaning very clearly that such a flow is nothing other than the steady drift of electrons in the reverse direction. Elsewhere in our subsequent work under the semiconductor, we will establish another useful concept of referring these three electrons as negative current carriers. Even then, we will stick to the conventional reference to the electric current as a flow from positive to negative terminal of the battery through the external circuit called a conductor. Generally, materials and alloys of metals show the property of conduction. On the other hand, materials such as silk, rubber, paper and porcelain are used to prevent the escape of electricity. These substances are classified as non-conductors or insulators. By virtue of the electrons being very strongly attached to the nuclei in such substances, they cannot easily be separated in spite of an external force. The flow of electrons in these insulators are so minute under comparable conditions